Hi everyone, thanks for joining the 10th session of What's New in Octave, the edge-to-cloud data orchestration platform by CR Wireless. Before we start today, I'd like to tell you that the team is really excited to continue to share with you every month new Octave features to enrich the possibilities of your IoT solutions and ease your development journey. We're also delighted to receive so many feedback from you all who are developing IoT solutions on the field with Octave and CR Wireless devices. So please continue to send your feedback and any feature idea you'd love to see and get in Octave. The Octave team is working for you. And speaking of Octave team, as you know, I always welcome members of the team to present these updates. And today is no exception. So let's welcome our first presenter, Frédéric Dur. Hi, Frédéric.
Hi.
Frédéric is a senior staff engineer, embedded software development at CR Wireless. And our second presenter for today, you saw him already multiple times, Augustin Mont-Saint-Jean. Hi, Augustin.
Hello, everyone.
Augustin is Octave's senior product manager. I'm sure you'll have many questions today for either Frédéric on the embedded part or Augustin on the world product, either on their respective today's topics or any other questions related to Octave is welcome. So send your questions at any time during the live using the question box or the chat. We'll try to answer you during the live when we can. Otherwise, we'll keep your questions for the Q&A session at the end. As usual, the session is recorded and will be posted on CR Wireless YouTube channel in the coming hours. If you are watching this on YouTube, check out in the description below for the link to register for the live sessions so that you can interact with the presenters next time. You know that there's two ways to join the session actually. Through your web navigator or through a dedicated app. Prefer the app if you want to interact with the presenters. Now, without any further ado, let's see what's on the agenda for today. So last month, we talked about the new file transfer feature. And today, Frédéric will complement the topic with ORP and we'll show you how assets on the edge can retrieve files using ORP. Next, we'll focus on the cloud side with Augustin, who will introduce a new plug-and-play connector for Azure IoT Central. Good stuff ahead then. And to finish with, as usual, we'll answer your questions in the Q&A part. And with that, over to you, Frédéric.
Hi, everyone. So I will present you so the file transfer on the embedded side, especially with ORP. So I won't detail ORP. ORP is Octave Resource Protocol, and it's a simple ASCII-based protocol in order to exchange data between your asset and the edge. So you have documentation on Octave website. So I provided the link, and you also have a public C client which is available and that you can use in order to be familiar with ORP by using C client which is human friendly, which has a human friendly interface. So here, I will just expose the ORP update made for file transfer. So we added some features in the ORP in order to be able to make some action on the device from the asset regarding the file transfer. So here in this feature and in this demo, the aim is to show you how an asset can retrieve a file which is stored in the device when such file was pushed from the cloud to the device. And so this C client was updated in order to provide some interface in order to make to have the possibility to control the device in order to retrieve such files from the edge to the asset. So you can consider this C client like an asset, like your application. If you want. So two specific commands were developed in this C client for file transfer, so file control command and reply data. So I will use both in my demo just after that. So the demo. So previously in the last session of what's new in Octave, session 9, a demo was made by the cloud team in order to show you how to push some files from the cloud to the edge. So here we suppose that we already have some files which are already stored in the edge. So now I just want to show you how to retrieve this file from the edge to your application. So to do that, I'm using a WP77 and the Octave version, which is embedded in this device, is 3.3 release candidate 6, which is already it's the last release candidate of this Octave version. And I will use two tools. So this famous public ORP C Client and just a simple SHA-256 tool in order to make a check of the file which was retrieved by the C Client tool. So first of all, I'll just show you maybe there's a GitHub web page linked to this ORP C Client. So it's available in the Sierra Wireless GitHub space. And you can think quickly, simple clone this C Client in your space. So when you retrieved this C Client, it's possible, of course, to make the binary. So, okay. Now, I just quickly connect to my device just to show you that the embedded version of the Octave embedded version is 3.3 release candidate 6. It's okay. So now I will connect my device. No, not my device. I will connect my host. So I will use the C Client in order to connect my host to my device. So I need to call the ORP binary. I need to indicate the serial port that I used for ORP. So this configuration can be made in the Octave UI interface, and you can activate ORP in the specific serial port, UART1 or UART2. You need also to specify the speed of your UART. And here I'm using a high-speed baud rate because it's better to use a high-level baud rate because it's possible to retrieve a huge file like, I don't know, 40 megabytes, for example, and in a low baud rate speed, it could be quick long. So it's better to use a high-speed baud rate. So when you connect the C Client to the device, to the edge, the first thing that you can notice is that you have some message which is received by the C Client from the edge. it's a synchronization message. This synchronization message is just to indicate that an asset needs to synchronize with the edge before it changes data. So you have some commands to make this synchronization, and I will use a specific one for file transfer, which is file control ready command. Okay, so this command is sent to the device, and the device understands that the synchronization is made, in fact. So if you want to use this C client, you have some commands that you can use. So it's available using the help command. And here I will use one generic API, one generic command, which is the get command. And I will use also some specific commands for file transfer, which is file control start. So suppose that we are now in session 9, and then in this session, some files were pushed from the cloud to the edge, and then these files are stored in the edge. Now, the asset wants to know which files are available on the edge side. To do that, using this C client, so you can integrate this C client in your asset, and in order to know how this protocol works. But if you use this C client, you can retrieve some resource value from the device by using the get command. And here we have a specific resource linked to the file transfer in order to retrieve the list of the stored file in the edge. And this resource is app files list value. So here I have the information of all files which are stored in the device. So it's a JSON data, and we can see that we have 3 files. The first file name is filetext 40M, which size is 40 mega. A second file which name is file2m.txt, which size is 2 mega, and a third one which name is file01, and its size is just 2 kilobytes. The important things in this list detail is the hash. The hash is a SHA-256 hash computed on this file. So this hash is sent by the cloud to the device and is provided to the asset in order to make the same computation when the asset retrieves this file, just to be sure that the file was correctly retrieved by the asset. So to retrieve a file from the edge to the host or to the asset, it's possible to request a file transfer. Using the C client, you have 2 modes. You have a manual mode and you have an automatic mode. I've just explained quickly the manual mode. So you can request to retrieve a file by using this manual mode by the command file control start, and then you indicate the name of the file that you want to retrieve. So for example, I want to retrieve this file. So now I retrieve a first data chunk of this file. So I've retrieved only 500 bytes. And here, the asset, so the C client, needs to acknowledge this data chunk. To acknowledge this data chunk, you need to use reply data 0. 0 means ACK, means OK. I retrieve the data, and you can follow to send me more data of the file. So in the C client, when we request to retrieve a file, all data which are received by the C client are written in a specific file. So, for example, if I go to, maybe it's too small. Sorry. So I need to just hack the first data chunk of data, and when I acknowledge this first chunk of data, we can see that a file was created in my host, and all data which are received by the C client will be written in this file. So when I acknowledge the first data chunk of data, I receive the second chunk of data from the device, and so I can reply. I can acknowledge this chunk of data. So you imagine that it's a little bit long to acknowledge all chunk of data which is received by the asset or by the C client, in fact, especially for use file. So we decided to implement in this C client an automatic mode in order to automatically acknowledge each chunk of data. So first, I need to abort the current file transfer. And now I can start a new file transfer using the same file. Yes, this one. And you have an automatic one by -A option, and you need to indicate the size of data that you want to automatically receive. So I indicate the file size, which is 2 MB. And here we can see that we have some data exchanges between the device and the edge. We have some sending, we have some received, which indicate that we receive data from the edge, and the C client acknowledge each chunk of data. So I need to wait a little bit the time in order to retrieve all data from the edge. Okay. Okay. Now all data were retrieved by the C client from the edge. So now I can exit from the C client. I can see that I have a file2m.txt file, which size is 2 MB. And now what I indicated at the beginning is that it's a good idea for the asset, so for the C client, to check if the retrieved file is a correct one. To do so, we need to compute the SHA-256 of this file and to compare with the provided one by the device, as indicated at the beginning in app files list value resource. So the provided hash for the file to mega.txt file is this one. So just for my editor. Yep. Okay. This one. So I copy paste the hash that I retrieve from the resource value, and also I indicate the file name because the tool requires to have such content. So I need to store this. Yes, genome client. See, I can hash.txt. Okay. I can quit the C client, so I have this my hash. So now I can call SHA-256 tool, which is a public tool, and by calling the file that I want to compute the hash, so I have this hash, and now I can call the tool in order to compare with the one which is provided in hash.txt. And here we can see that the hash is the correct one. So now we are sure that the file which is retrieved by the C client, by my host, so by your asset, for example, is the correct one. And the last possibility that you can do using the asset in such case, we advise when a file is retrieved by an asset to delete this file. So this can be made by calling the main issue is that I don't remember the command is something that with this push JSON. It's possible to push a data in a specific resource, which name is app files control, and it's possible to indicate the file name of the file that you want to delete from the asset on the device. So it's possible to send a command from the asset to the edge to delete the file which is stored in the asset. And then if an observation was created before in this specific resource, in the file list resource, which is app files list value resource, the cloud will be automatically notified that this file was deleted on the edge. And so it's possible to retrieve and to control all files which are stored in the device.
All right. Thanks, Frédéric. Any question for Frédéric on his part? I don't see any question on the chat or on the question. Yeah, I have. Thank John for your question. Is it possible to handle unsolicited data from the cloud?
Unsolicited data from the cloud, you mean to what kind of data? Yes. And so from my point of view, you can, yes, link to file transfer. So you have one specific resource, which is app files list value, which can be observed by the cloud. And every time a new file is available on the device, and each time a file is deleted on the edge, the client can be automatically notified. I don't know if it answers to the question. What kind of unsolicited data which are required? So
John is saying anything like, for instance, receiving a string that says, for instance, turn the pump on, or any kind of unknown data in advance.
So it's more like a file upload. I mean that the possibility to push some file or to push data, that maybe more to push files, in fact, from the asset to the edge and then to the cloud. So pushing data is not possible for the moment. it's only possible to push files. So we are talking about files, to push files from the cloud to the edge, and then from the edge to the asset. The possibility to upload such file from the asset to the cloud is not supported for the moment. It's under, we are thinking about this in the near future, but it's not for the moment implemented.
Okay, so just like currently you can send through, I mean, you can use ORP. ORP supports unsolicited data from the cloud, so coming from the cloud, like
Yes.
if you to set a parameter like speed
Yes.
equal 20, for instance, or something like that. But is that the same thing with file transfers? See what I mean?
Yeah, it's not the same. You can push data in a specific resource, like a virtual resource, and it's possible using ORP to subscribe on this resource. And when this resource is updated by the cloud, the asset can be notified. And it's the same. If you want to push some data in a specific resource from the asset to the edge, and if an observation is created in the cloud in this resource, when the asset pushes data in this resource, this data would be pushed to the cloud also. But
okay.
it's not files, it's just data in fact.
Yes, okay.
Yeah, so in summary with ORP, you have two-way real-time and I would say unsolicited data downstream or upstream through native ORP resources, which the maximum size is 50 kilobytes, which is already pretty big. So you can use that both ways. And then for larger payloads, basically, or if it's actually a file, you can use file download, so only in the download way to download it to the WP and through what Frédéric demoed down to the asset. So typically to carry configuration files that the asset needs or to do a firmware update on the host itself.
All right, thanks. We have another question. Is the code suitable for microcontrollers outside an operating system, so with no operating system?
Good question. I don't have the answer. I know that I need to check this one.
All right. So yeah, so thanks for this question. So I guess we can continue this discussion on the forum, because just as a reminder, the forum is the right place to interact with the team, including Frédéric and Augusta. And that's really the kind of question you want to ask on the forum and get it answered. Or maybe if you want to try things and so on, you can get support on the forum as well. So thanks for your questions. I don't see any further questions for this part. So thanks, Frédéric. I'm gonna switch over to Augustin now, so that we can continue for the cloud side on the second part of this session. Augustin.
Yeah. Okay, should be sharing my screen now. Can you see it?
Yes.
Okay, good. So yeah, hi everyone. So what I'm going to show you today is a follow-up on the session we did, I think it was 2 or 3 months ago, I don't recall exactly, on our set of enhanced connector to Azure IoT Hub. So you've been able to follow the how we improve these connectors, and now we went one step further to really make the whole the whole connector handle an easy way with Octave to develop your use case and immediately have a cloud hosted application in IoT Central in a few easy simple steps, even for non-experts. So just one slide to cover what we had seen in the previous sessions. If you haven't participated, you can watch the replays of those sessions. But Basically, our IoT Hub plus DPS connectors handle native interfacing of Octave devices with device twins in IoT Hub, so reporting telemetry, subscribing to commands coming from the IoT Hub. And the key part is ensuring some two-way mirroring between the Octave device object and the device twin, which is the representation of the devices in IoT Hub. And what the device provisioning service that we added handles, it's security and bootstrapping. So rather than having to manually provision devices in IoT Hub and provision them with their keys in IoT Central, you basically give create groups with global keys in the device provisioning service on the Azure side. And based on that and on keys that you provide to the connector, Octave automatically enrolls or asks the Bootstrap to enroll your devices if they're allowed. And this also directs them, so does load balancing and everything that would be needed on a scalable system. Now, one step further is, as you'll see, is it simplifies all this by using IoT Central, which is on the Azure side. It's a predefined environment to build IoT-based applications where you can really simply create dashboards to visualize data or settings, and also to control devices. And to do so, you need to model your devices, and this somehow matches the equivalent of the device or the key parameters of the device blueprint. And so I'll show you how to model that and how existing templates can also be used. And everything which is related to the IoT Hub itself, device provisioning service, etc. This is handled by the connector and by IoT Central, but it's really obfuscated, meaning it's running, but it's not, you don't have to do anything about that specifically. So I'll show you the steps to really build an end-to-end solution. So including your own assets, an Octave device, Octave itself, and IoT Central. I'll show you that to you on the following slide. It's really simple, but basically what we've added to do that on top of the existing connector is add what we call a PNP plug and play / IoT Central mode. So it's basically one box to tick. And when you enable that, it's the Octave connector, which automatically models anything that the Octave device reports to a format that is understood by IoT Central and allows to do the two-way mapping. So let me just move that to see my slide fully. So what this really enables, also this Octave plus IoT Central based on our latest connector, it's really simple to build an end-to-end application, and there are basically 4 steps, and actually 3 steps that you need to go through. The fourth one is just operating the system and adding devices. So the first one that all know really well is you have a use case, some assets to control. So you create your blueprint and add tags to your devices. The tag just being to match the device to the connector, and that's it. So I'd say the usual things you are used to in Octave. Then the second step is just go to the Azure portal, create an IoT Central application. That's the main first step. And the second part is create a device model that will match your use case. So basically, on top of generic Octave resources and settings that you can import from the models we provide, you basically just need to update the telemetry part to cover whatever is specific to your use case, and update the system with whatever specific settings or virtual resource typically that you need to control. So simply editing a JSON model in the UI to adapt to your use case. So a fairly simple second step. And the third step is really simple, is simply to set up the connector. So it's basically going to Octave UI, add a connector, select the tag. I'm going to show that to you in the interface. Select the tags to associate your device. And there's just one identifier and one key to configure, which is our 2 identifiers, which are provided in your IoT Central application. And once you've done so, basically, your system is up and running, you can fully monitor your telemetry and control your devices. And the only thing you need to do on top of that is when you deploy new devices, add them to Octave, so provision them in Octave, obviously provisioning them with the appropriate blueprint and tags, so things that you can do by bulk import. Just import all your devices with blueprint and tags, and they will automatically show up in IoT Central with the proper model. So the end-to-end provisioning is really simple. So here I'm just showing up the framework that I'll use for the demo. It's quite a standard demo that we've been using for some time, but now fully handled by this plug-and-play connector. So on the edge side, we have an FX30, which is collecting some Modbus data, running a simple edge action, which compares the live readings to thresholds that we will control from the cloud. And depending on the readings compared to thresholds, it sets a relay on or off to control a fan in a greenhouse, and it reports telemetry. It actually reports telemetry at different rates, so using the edge orchestration capabilities based on the alert status. So on the Octave side, really simple and things you are used to. And then the key part is that by just adapting the templates in IoT Central, so adding the 2 thresholds and mapping the 4 telemetries, so 3 environmental readings and the status of the relay, just model that in the template. And from there, you just build a dashboard where you can monitor everything and control everything. And everything that's working, all this represented in Octave, is fully handled automatically under the hood. So this is pretty much the same picture. So we have something like 15 minutes left. So I'll speed up a bit and show you the actual demo and setup. The key part to understand, maybe because I guess you've understood the connector part, the key part is really building or updating the model in IoT Central. So what we do, so it's JSON models. So we provide, you'll see in our documentation, we have a predefined model which handles, I would say, Octave generic services. So things like cloud interface, so store and forward, developer mode, reporting seller signal information, handling the timer and things like that. We have a generic model that you can import and it will be ready to use immediately. And then there are just use case specifics that you will want to add to that model and show you how to do. So typically in my use case here, I have 2 virtual resources, which are thresholds. So I have updated the model to handle those 2 virtual resources. And I also have, as I said, 4 telemetry data points that I collect on top of the cellular and generic information. So I've modeled those telemetry points as well to be able to show them. Oops, sorry. So now let's switch to the actual user interface. So I have different screens here. So this is my device in Octave. So what usual things you can see I have a couple of edge actions, a couple of observations, and my data. I have some data reported in multiple streams. So the result of my edge action reported in default stream, and I have some seller and signal information which are reported in their own specific streams. So that's the edge part, and I won't show them to you, but in the resources, I have 2 virtual resources that are thresholds, and I'll show you how to model them in IoT Central. So that's for the edge part. Now just showing the device here. So to enable it, for it to be handled by the connector, you need to map it through a tag. So I have 1 tag here, which is related to the connector, and you need to set the IoT Hub enable flag to true in provision or provide a given Azure related name to that device. And once you have done so, what you see here is the result of enabling these. The connector registers the device in IoT Central and assigns it under the hood to specific IoT Hub automatically, and it's able to keep track of any time someone does an update in the application. We know versioning of the devices, so you can see this to make sure that the device is fully aligned with what people have changed in IoT Central. So the connector itself, I've covered that last time, so it's pretty much there. I won't go back through all of it. Once again, you can have a you can review the presentation if you want to know all the details here, but just one as a summary here, the keys that I provide here and hidden here are keys that are provided in my IoT Central application. So this is the application here. If you go to administration, in the device connections, it gives you a scope and a key. So just basically copy that, copy these in the connector, and from there, any device linked to the connector with that tag will show up automatically in IoT Central. The other thing I do is I use the connector to collect information from any stream on my devices, which report data. So here's default for data reported by my edge actions, but also I'm collecting information from the signal and sales observations. So the connector allows you to aggregate things coming from any streams in the devices. And one thing, it's not mandatory, but one thing I do to organize things well in the IoT Central model, anything coming from those streams, I just push it as something tagged under a telemetry key, and makes things, the modeling in IoT Central easy. So here, oops. So this demo, as you can, this device, as you can see here, it's a FX30. We've used it for a trade show, a CEDO demo. So this is how it's named. And if I go back to IoT Central, you can see that I have a device which has that specific name. So with IoT Central, you can build any dashboards. I won't expand on that. It's no code UI building. You can build as many screens as you want. So that's it's really easy to adapt it to what you need to have, but it has little interest for me to show you how to do that. That is really easy. I'm rather going to focus on what you can do and how to adapt or update your model in IoT Central to map your Octave blueprint. So here, what it is showing are some data which are reported from the device. So the thresholds of virtual resources, I have two thresholds, 61% humidity, 48 degrees in temperature. So actually, if we look at my virtual resources, that's what we would see. And I can see real-time data. So the telemetry, the actual humidity measurement, and the temperature measurements. And since the data, the values are below the thresholds, my fan is not enabled. Now, something that I can do, so here you can see my device, it's just reporting data, but there's nothing, it's fully synced with the cloud. Now, if I change a setting, so now I can go to my dashboard here, where I have all the Octave or most of the Octave properties models, so the dev mode, the store and forward, enabling the seller data reporting, the signal level reporting. So generic Octave things that you can have, and also some parameters that are specific to my use case that I have modeled. So the thresholds that I was mentioning. So what I can do here, for instance, I can reduce the threshold for temperature and save. And once you do that, you see my little icon here is spinning, and Octave has immediately received information from the connector that it should change some properties on the device. So it changed the actual properties for the virtual resources actually. So push was configuration was pushed to the device, and we've got the completion of that. So if I go back here to IoT Central, you can see that it has been accepted, meaning the last change I did was having desired value of 16 on that threshold, and the latest thing that the device reported is that it does actually get 16. If I increase it to 17, actually, you can go here. It's asking for 17, but device has not reported the 17 yet, but it will come soon. So here you have full sync of and full view, and has been accepted live. So you change your settings. it goes to Octave automatically, and whenever things have been changed, so whether your device is online and this happens within seconds, or if the device is out of coverage or offline, things are handled by Octave automatically, and whenever the device will be in reach, it will apply the settings and report back to IoT Central that the properties have changed. So now that I have decreased the threshold, the fan is now enabled. So that's telemetry that I'm reporting. So the device is changing the relay value when the thresholds are too low, and it's also reporting its data. I also have some other information, so generic telemetry and information that we collect from the cells and signal information. So I'm able to display the radio access technology, the RX level, and just have a summary of developer mode and which sensors or generic Octave services are enabled. And it's easy to have little graphs about the telemetry. You can also, not going to expand here, just as examples, you can also build many kinds of graphs. So maybe now showing you what actually happens under the hood. So whenever I change properties that I just did a few minutes ago, in the meantime, I had quite a lot of telemetry because it's reporting at a high rate. Actually, I'm just going to increase the value again just to reduce the rate of telemetry. To save that. Okay, so I changed the property. I can see it has been pushed to Octave and it reported new values back. I'm not going to enter in the details, but here you have a detailed view of everything that is pushed to the device and what the device answers. And you also have a full list of all the telemetry which is reported by the device. So that's the raw data. And assuming you have, so everything, even things you have not mapped. So if your device is reporting 20 information in terms of telemetry, what IoT Central will do is it will show you everything that it gets, anything that it knows in its model. It will show it to you in the proper column. So it knows that this is seller information. It knows different kinds of values, so humidity threshold, the SIM information, and things like that. And if there's information that is reported that it does not know, whether it's properties or telemetry, it shows it to you. There's another screen where you can go and basically ask it to analyze what's coming through, and it suggests you to add any new data point, any new entry to the list of telemetry. So that makes it really flexible. You build your edge action, it reports what you need to report, and then in IoT Central, if you haven't modeled everything, you can just go to that page. There's a specific function that you can find in IoT Central documentation. It will analyze what's coming through and add all these entries to your device model. So basically, just showing you the device model pretty quickly and leave the floor open for questions. So this is basically how the Octave device is modeled. So if you go to the documentation, so Octave documentation on connectors, and look at the plug and play IoT Central, you'll see that we provide a generic model, which includes the model for this demo typically. So all the generic Octave settings, but also the specific settings that we're using here. So to give you a sense of how this works, basically, we have one main object, which is of type telemetry, and which names, that's the important part, the name, so it's the highest level in the hierarchy, is called telemetry. And this basically corresponds to the fact that in the connector, if you recall, here I'm pushing everything under telemetry. So anything coming from in my events, I'm picking up the LMs part, pushing it under telemetry. So it's received in that kind of format. And what I tell IoT Central and the model is that everything that comes under telemetry, get ready to receive an object which can have all of these entries. So either flat at the highest level, but also you can see here, so the UI here is a bit, the UX could be enhanced, but this is the util part. So I'm reporting something which is, so let's say I'm reporting temperature, humidity, dew point, but also reporting util, and under util there's seller, signal, RX level, and RAT. And this is the way you model a hierarchy of telemetry. It's very simple to upscale this to any format of telemetry you would be reporting, and that's what a simple way of doing it is put everything under telemetry, and then you build your telemetry resource tree. And now, in terms of of modeling the device, I'm going to show you the cloud interface, for instance. So to model properties, what we're doing here, it's not telemetry, it's property. So you build a model which are properties and which have an identity here. The key part is that the name here is important. It's cloud interface with the exact same format that then the resource tree in Octave. Sorry. So here I have modeled cloud interface at the highest level, and anything that I want to use under cloud interface, I create a property which is developer mode. So once again, going to the tree here, I have developer mode, and I have enable inactivity period, close on inactivity, and I have modeled this as an object which is enable, close on inactivity, and inactivity period. So that's for cloud interface developer mode. We have a similar part for cloud interface store and forward, and you can do the same for location or for Octave utils. Here you can see I have util and all the structure that we can have under util. So, and this is what we provide in the default template because it's common to all Octave devices. Now, for instance, for the part which is specific to my use case, where I have both thresholds under virtual resources, the approach is simple. You create another another component, which is called virtual. And from there, I'll be able to control any virtual resource, provided that I provide the proper schema. So I have virtual/temperature and virtual/humidity thresholds, which are actually the way that the virtual resources that I'm using to set my thresholds. So you just need to model that. And so that's typically the part that you would have to customize along with the telemetry. You model and adapt these to match your Octave blueprint, basically. And once this is saved, you have a device template. Oops, let me just go here and go really quick. Have a device template, so mirroring your blueprint. And this device template has a main identifier, which is here. And what you can do in the connector, you can basically just report that ID here, which means that now anytime everything is set up, so if ever I add another FX30 to IoT Central, and I can kind of fake that by using another device, and I will just basically change its name here. Whenever I do that, IoT Central takes that as a new device. I don't know if it will have time to show up within the seconds which are left, but it will show up. You can see it did it. So ITC3, the one that I just kind of virtually created, and it's seen as an Octave greenhouse template. So this device here obviously didn't have time to report a lot of the telemetry, but just like I've just added a new device to the fleet, and it automatically shows up in IoT Central with a proper dashboard, and I can immediately start controlling it from the UI here, collect telemetry. You can see I already have one telemetry which has been reported, and I can control that device immediately. So really, really simple and flexible. So yeah, leaving a few minutes for questions.
Thanks, Augustin. All right, is there any question for Augustin? I don't see any questions so far. So let's jump to the Q&A ending part. If you have any questions related to Octave in general, not only for the topics of today, please send your questions. Augustin and Frédéric can answer those questions. Maybe Augustin, you want to display the slides?
Yes, sure.
No question so far. So either on this nice plug and play connector to IoT Central or any other Octave question? No? All right, so in any case, feel free to interact with the team on the forum, either for your technical questions or for any feature or anything you'd like the team I mean, anything you would like the team to answer. All right, so I guess that's we are right on time to wrap up this session. Next time, November 18th, so in 1 month and a half. So you have more time. If some of you guys, we had some discussion for interacting with these sessions and maybe presenting what you guys are doing, your use technology of interest you would like to share, that is linked to Octave. So please contact me. You have my email here. You can register obviously for the next live sessions. You can follow us on Twitter, obviously, and if it's not already the case, you can subscribe on our YouTube channel. Thank you, Frederic, for this first participation for What's New in Octave. Thank you, Augustin, once again. Always a pleasure to have you here. And thank you everyone for attending this session. See you next time in November.
Thank you, everyone.
Bye-bye.
Goodbye.
Bye.